And so one question that was asked several times is why shutdown price is equal to the minimum of AVC, and similarly, why the exit price is equal to the minimum of AC. So there are similar problem. I'll only solve this one. So there are two types of explanation that I gave. One is in the slides, and the other one is the one I did in the lectures. So the one in the slides is more thinking, and the one in the lectures I gave I think is simpler because it's just mathematics. So I will do both of them and show you that they are actually the same. So the common thing is a firm, as I said in the lecture, it should shut down if our profit is less than or equal to minus the fixed cost. So or equivalently, as I said, is when its loss is larger than or equal to fixed cost. These two lines are exactly the same. It's just I just put a minus in front. Minus profit is loss. Minus FC is just FC. So the one that I gave in the lecture is I said this needs to be true for all x. So first, this notation is called for all. And secondly, why you need this to be true for all x is because if we are producing at some point that's not efficient and it's making a large loss, it doesn't mean that if we change our production, it's still making the same or even more loss. So we want to choose an x such that we can minimize our loss. But if after we have minimized our loss, it's still the loss is larger than fixed cost, then it's the time to shut down. So if we produce at some wrong quantity and the loss is huge, that's not the reason why we shut down. We want, when it's every possible quantity we produce, we are making a loss larger than fixed cost, that's when we shut down. So that's the main idea in the proof that I use in the slides. So given that, I think the rest is easy. So we have px minus cx. This is the definition of pi xp less than or equal to minus fc. This is true for all x. And then doing some small algebra, this is making fc appear on the left hand side and dividing it by x, we get to p smaller or equal to, move this to the other side again, AVCX for x. So at this step, you need to think a bit. So if P is smaller than AVC at every x, what this means is P is smaller than a bunch of different things. Then if P is smaller than the smallest of them, then automatically P should be smaller than every one of them, and vice versa. If P is smaller than the smallest, then I mean, no. If P is smaller than everything in a group, then P should be smaller than the smallest of them. So that's how we get from the for all to the minimum AVC of x. So one possible cutoff, which is what we mean by shutdown price, is the P that separates the thing that we want to shut down and not shut down is when P is equal to this. So, and the explanation that I give in the lecture is, I would think, is more straightforward. So I just wrote pi as a function of P being less than this. So by definition, this means we don't care about x, so x is already maximized. So this is the maximum of x, P minus this. Or if you want, it also can be px star minus cx star. This is less than fc. So moving this to the left hand side again, divided by x. So this is like this. And divide this by x, we get the maximized P minus AVCX is less than or equal to 0. So So the mathematical trick here is when you want to move the operator max inside the minus sign here, basically if you are maximizing the negative of some number, it's the same as having a minus in front but minimizing the thing inside. So that's the main mathematical argument. When you want to move the max operator inside a minus sign, we change it into a minimum. So P stays there, and this is less than or equal to 0, and then you can move it to the other side, which then you see that these two are exactly the same.